Hi guys, Dallas here, and today we'll be continuing STEAM jobs in space exploration. Now, the other way, let's get into it. Sorry for that, I had to do the thing first before I did that. Searching for ETs. One branch of astronomy focuses on the search for habitable planets outside our solar system and evidence of intelligent life beyond Earth. One of the most famous projects to search for extraterrestrial life are SETI, use telescopes to scan for radio or electromagnetic signals from alien civilizations. Other astronomers focus on data and photographs obtained by robot spacecraft sent to underworld to see if microscopic life forms like bacteria can exist on moons and other planets. Real STEAM job. Planetary geologist. Planetary geologists travel to locations on Earth, like regions found on other planets. Volcanoes were discovered on Jupiter's moon, Io, at low. Planetary geologists went to Hawaii and Iceland to study volcano formation. When New Horizons sent back data for glaciers on Pluto, scientists traveled to cold regions like Antarctica. And when astronomers discovered exactly what rocks are found in comets, they studied similar rocks on Earth. Steam fast fact. Using robot spacecraft, astronomers discovered that Europa, a moon of Jupiter, and Scandalus, a moon of Saturn, have liquid water oceans beneath their frozen surfaces. Scientists theorize that these oceans could possibly harbor microscopic life or even alien sea creatures. An array of radio telescopes scans the sky for signals of advanced intelligent life beyond our solar system. A geologist studies volcanoes on Earth to understand volcanoes on other planets and moons. That blur out steam. Katie. Steam spotlight. For a long time, astronomers theorized there were planets outside our solar system. Scientists proved the theory in 1998 by making observations of stars. You notice that from time to time, stars dimmed, then brightened again. Astronomers realized this occurred because planets were passing in front of distant stars as they orbited. Since then, more than 3,000 exoplanetary systems have been discovered. Most of the credit goes to Kepler Space Telescope, launched in 2009 to find Earth-sized planets around other stars. Kepler discovered planets bigger than Jupiter orbiting as close to its sun as Mercury orbits our own. Space Telescope also found an exoplanet that might be made entirely of diamond, and more than 500 rocky worlds are larger than Earth and can have liquid water oceans. 4 minutes. Steam in action. Astronomers determined that chemical composition of stars with known exoplanets using a method called spectroscopy. Spectroscopy breaks down visible light like sunlight, which looks white, into a spectrum of different colors. Combined two other methods that compare those colors to different wavelengths that specific gases emit. Astronomers can determine the physical composition of stars. See how visible light separates into different colors of the spectrum by using a prism. Hold up the prism to a light source like an open window at daylight, or shine a flashlight through it. Make sure any light that goes through the prism shines on a white wall or a blank sheet of paper. What colors do you see? Write them down or use colored pencils to draw what you observe. Try shining different colored lights through the prism. What color do you see now? What kind of looks bluish? Bluish white. Infinity and beyond. Astronomers collect data on things we can see. Other astronomers take the information and formulate theories on how the universe forms, how the universe could possibly end, and even if there's a universe other than our own. Using data from ground-based instruments as telescopes, astronomers were able to map the boundaries of the known universe. Steam fast fact. Albert Einstein, 1879 to 1955. The most famous theoretical physicist is Albert Einstein. His ideas continue to influence astronomy and space exploration today. Einstein's theories on space, time, and gravity help scientists understand the origin of the universe, called the Big Bang. And a continued expansion, yes, even after its birth 13.7 million years ago, the universe is still growing bigger. Real Steve Jobs, theoretical physicist. Theoretical physicists seek to understand the physical laws governing nature. They study forces such as light, gravity, and magnetism. Then they create mathematical equations based on these forces to illustrate how the universe works. Theoretical physicists focus solely on research. Some are college professors. Others work for NASA space programs or private aerospace companies to help them refine products and services. Solar system, interstellar neighborhood, Milky Way galaxy, local galactic group, Virgo supercluster, Loc superclusters, observable universe made of local superclusters, made of Virgo superclusters, made of the local galactic groups, made out of galaxies, made out of interstellar neighborhoods, made out of solar systems, made out of planets. That's a lot to think about. Steam in action. Gravity is one of the most powerful forces in nature. It keeps us from spinning into space. Gravity also keeps the Earth in orbit around the sun. You can feel it when you jump up. You come back down because of gravity. To find out more about how gravity works, gather 3 paper clips, string, a stick, tape, metal ruler or strip, 3 strong magnets, and some blocks to stack. Tie a piece of string to each paper clip. Then tape the open end of each string to the stick. Make sure you tape them evenly across the length of the stick. Now lift the stick and watch what the dangling paper clips do. Where do they point? Tilt the stick to the right or left. What happened? You're observing the force of gravity. Now take the magnet and put them on the metal ruler. Face evenly like the paper clips on the string. Place the ruler with the magnets facing down, with each end of the ruler resting on a block. Take the stick with the paper clips and put it under the magnet. Make sure each paper clip is lined up with each magnet. Describe what you see. In this example, the force of magnetism was stronger than gravity. Cosmologists studied the vast expanse of the universe. This map from left to right shows increasing distances in scale, starting from Earth and ending at the limit of the known universe. So the planet is nothing more than a faint dot in the entire observable universe. Is that little red name? Every single one. Observable universes are made of local superclusters and local superclusters are made of virtual superclusters, and those are made of local galactic groups, and those are made of galaxies, and those are made of solar neighborhoods, and those are made of solar systems, and those are made of planets. Real same job. Cosmologists. Cosmologists use universal data and the most current theories to answer big questions. Did anything exist before the Big Bang? Exactly how big is our universe? When will our universe end and how? Cosmology looks at the big picture and is basically the study of large scale properties of the universe as a whole, according to NASA. Seven minutes already. Things following. One of cosmology's big discoveries is the evidence of dark matter. Scientists say that the observable universe, the stars, planets, and galaxies we see with our own telescope make up only 4% of the entire universe. The other 96% is filled with an unknown force of energy that cannot be seen, detected, or even easily understood. Hence the name dark matter. How do astronomers know that dark matter even exists? Because scientists can observe the gravitational influence of dark matter on the things we see, like galaxies, so the universe, which is vast to begin with, is mostly filled with invisible stuff. Astronomers observe light from distant objects bending before it reaches Earth, which is a telltale sign of the presence of dark matter. Cosmologists and theoretical physicists don't look across the expanse of the universe. Some scientists use powerful microscopes and other specialized equipment to peer into the structure of atoms and other subatomic particles. All matter in the universe is made of atoms, and learning more about how they behave gives physicists a deeper knowledge of the cosmos. Scientists use electron microscopes to study the intricate structures of and composition of rocks and sand from the moon or comets. 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 Yeah, comets. Comets. Already 1318. Fast fact. The large Haldon Calder, Lich, is in Switzerland is the largest machine in the world. Scientists run experiments by sending particles around its 17-mile, 27.33-kilometer circumference, smashing atoms together to create even smaller subatomic units. The LHC was built to help physicists prove theories about dark matter, the creation of the universe, and other unsolved mysteries. Scientists continue to pursue those answers. The ledge smashes groups of protons together 40 million times per second. That is near the speed of light. Computer programming for the space age. Space explorers use special tools to do their jobs. Telescopes to view the heavens, robots to explore planets, and rockets to voyage to space. All of these machines need computer engineers to build software and run programs, collect important data, or reach their far-flung destinations. See you in action. The Calculators that you find at school or in your home are more powerful than computers used by NASA to put astronauts on the moon. The computers at the Apollo mission had 64K of memory, and the processors ran at 0.043 megahertz. Go to your computer to find out its technical suspicions. How fast is your computer compared to computers from the 1960s? Do you have a gaming console like a PlayStation or an Xbox? How fast does it run compared to the Apollo mission computers? Modern pocket calculators have far more memory and processing power than the computers used in the Apollo 9 mission. With future missions planned for the moon, Mars, and beyond, STEAM workers and space exploration will advance our knowledge of the universe and opportunities to explore our world. In space exploration, the sky is not the limit. Real STEAM job. Computer engineer. More than 60% of the functions at NASA require engineers. Space Energy looks for computer engineers and computer scientists, program code, and create software that guides spacecraft to distant planets, instruct spacesuits to monitor vital signs, and tell deep space probes where to point cameras to send photos back to Earth. And that's it for this video, this book, and after this video, hope you guys enjoyed. And see you again very, very soon. Later.